This video is about classifying triangles by sides, classifying triangles by angles, applying the triangle sum theorem, using the exterior angle theorem, and using coordinate geometry to understand triangle relationships. So remember that triangles can be classified by two different properties, the sides or the angles. The sum of all angles in a triangle is 180 degrees. So first let's look at classifying triangles by angle measures. So when we classify triangles by angle measures, there's four types. The first one is an acute triangle. In an acute triangle, all angles are less than 90 degrees. So for example, we might have a triangle that could be 40 degrees, 50 degrees, and 60 degrees. An equal angular triangle means that all three angles are congruent. This only happens when they are 60 degrees, which should make sense because remember the sum is 180, and if we divide by three angles, they all have to be 60 degrees. So in an equal angular triangle, all three angles could be marked congruent because they're the same, and they're all going to be 60 degrees. In a right triangle, one angle is 90 degrees, and other two angles are acute. This must happen because if one angle is already 90 degrees, I can't have another angle that's 90 degrees or bigger, otherwise it won't make a triangle because it can only add up to 180 degrees. So in a right triangle, we have one right angle, and then we could have something like 40 degrees and 50 degrees. The last type then is an obtuse triangle. So an obtuse triangle, one angle is greater than 90 degrees, because remember an obtuse angle is greater than 90, and other two angles are acute. So for example, I might have a triangle that's 120 degrees for the acute angle, and the obtuse angles might be 20 and 40. So let's classify the triangles by angle measure. So the first triangle that we want to look at is BAE, so angle BAE. Well, right now I need to fill in the remaining angles that are missing. So I know if I have one right angle, next to it has to be a right angle because it's forming a straight line. To get the angle on the top, I can take the two angles I have, 90 and 47, and subtract from 180. So 180 minus 90 minus 47 will get me an angle of 43 degrees. So in this case, angle BAE, because it has a right angle, is a right triangle. My second triangle that I'm looking at is EAR. Now in EAR, we have a 90-degree angle, we have a 31-degree angle, so to get the last angle, 180 minus 90 minus 31, which will get us an angle of 59 degrees. So again, this angle is also a right triangle because it has one right angle. And then our last triangle to look at in this picture is BAR. So BAR is the whole triangle. Remember up top I have an angle that's 43 plus 31, which gives us an entire angle of 74 degrees. So all of these angles are less than 90 degrees, which means that this is an acute triangle. Now when I move over to triangle number 2, the first triangle is CAR. So in CAR, I need to know the missing angle. Well, if it forms a straight line, I can subtract 60 and get a measure of 120. So one of our angles is greater than 90 degrees, which means that this is an obtuse triangle. The next triangle it wants us to look at is ART. Well, in triangle ART, I have 180 degrees minus the two angles of 60 I know. To get my other angle is 60. So all three angles are 60 degrees, which means they're all congruent. So this is an equal angular triangle. And then the last triangle to look at would be CRT. And this angle on the top, if I have a 30-degree angle and a 60-degree angle, that makes 90. So this must be a right triangle. Now, the other way to classify triangles is by the side measure. So in an equilateral triangle, all three sides are congruent. So they're all going to have the same measure in the triangle. So they might have all the same tick mark, and they're all going to have the same measure. An isosceles triangle, then, has two sides that are congruent. So in an isosceles triangle, it can look like this, where the legs are congruent and the base is a different size. Remember that the base does not always need to be on the bottom, so if I draw it looking more like a pennant, I still have an isosceles triangle with my base being 8. Remember that base does not mean the side you're laying on, it means a side that's not the same in an isosceles triangle. And then our last type of triangle is a scalene triangle, where all three sides are different measures. So for example, I might have a triangle that's 4, 6, and 9. So let's classify the triangles by side measure. So the first triangle that we are looking at is BAE. So in BAE, we have that tick mark, which means if this side is 10, this side is also 10 because they're congruent. So because we have two sides that are the same measure, this is an isosceles triangle. Our next triangle then is EAR, and in EAR, all of the sides are different measures. So this is a scalene triangle. And the last triangle to look at is BAR. So be careful with BAR because we need to look at the whole side. So from B to R, remember that 10 plus 7 gets us a side of 17. So we actually have two sides that are 17. So again, we have an isosceles triangle. In number 4, the first triangle that they want us to look at is CAR. Now, remember, if we look at the triangle that's not highlighted, there's tick marks in it, which means that all the tick marks have the same side, congruent, so this is also 11. So in CAR, all the sides are different, so this is a scalene triangle. In the next triangle that we're going to look at, ART, all of the sides are the same, so when they are all the same, it is an equilateral triangle. And last, when we look at angle triangle CRT, we have a side that's 11 and a side that's 14, and we need to add on the bottom to get the last side is 17. Again, we have all different sides, so this is a scalene triangle. So number 5, the perimeter of triangle CUB is 53 inches. Find the length of each side and classify the triangle by its side. So remember that perimeter, in order to find perimeter, you add all the sides together. So we have x squared plus 2x plus 3x plus 6 plus 5x minus 9 is equal to 53. So when I combine like terms, I get x squared. I add my x's, so 2 plus 3 plus 5 is 10x. I combine my numbers. 6 minus 9 is 3, is equal to 53. So in order to factor, I need to move everything to the x squared side. So I'm going to subtract 53 from both sides. So I get x squared minus 10 or plus 10x minus 56 equals 0. So I need two numbers that multiply to 56 and add to 10. So I'm going to have x plus 14 and x minus 4 equals 0. So when I solve, I get x is negative 14 and x is 4. Now in this case, negative 14 doesn't work because it would make this side length a negative, and we can't have negative side lengths. So I'm going to use the 4 to find all of my side lengths. So I'm going to do 4 squared in the first side plus 2 times 4, which gets me 24. Then I'm going to do 3 times 4 plus 6, which gets me 18. And last, I'm going to do 5 times 4 minus 9, which is 11. Notice that all the sides are different, so this is a scalene triangle. So the triangle angle sum. The sum of all angles in a triangle is 180 degrees. There's also a shortcut. So if you have a right triangle, then the sum of the acute angles has to be a right triangle. So it has to be 90 degrees, which should make sense because if I have a right triangle that's already 90 degrees, that means the last two angles must also equal 90 degrees when they're added together. So let's use these ideas to solve for x. So in number 6, we're going to add all of our angles together and set it equal to 180 degrees. So when I combine like terms, I have x plus 4x plus 5x gets us 10x. And I have 29 plus 11, which gets us 40 equals 180. So we're going to subtract 40 from both sides and then divide by 10. And x is 14. In number 7, we actually have two triangles. So we're going to start with the triangle that has two measures. We're going to start with the triangle that's on the left. So to solve for x, if I already know two of the angles, x has to be equal to 180 minus 62 minus 43. So when I subtract those angles, I get that x is 75 degrees. Now remember that x and y are vertical angles, which means that y is also 75 degrees. To get w, I know that w and x form a straight line, so I can subtract 180 minus the angle I know to get that w is 105. Then I can move to my triangle that's on the right and highlight it in blue to get z. So to get z, again, I know that my triangles are 180 degrees. So 180 minus 75 minus 48 will get me a measure of 57 degrees for z. So number 8, solve for x. Again, we're going to add all of these angles together and set them equal to 180, the triangle sum. So x squared plus 59 plus 6x plus 63 plus 4x plus 19 equals 180. So when I combine like terms, I get x squared plus 10x, 59 plus 63 plus 19. So plus 141 is equal to 180. Because there's an x squared, this is going to be a factoring problem. So I'm going to subtract 180 from both sides. So x squared plus 10x minus 39 equals 0. So I need two numbers that multiply to negative 39 and add to 10. So I get x plus 13 and x minus 3 equals 0. So x is equal to negative 13 and x equal to 3. In this case, negative 13 won't work because if I put in the angle on the right, I'm going to get a negative number, and we can't have negative angles. Number 8, Solve for x. So first thing I want to do is I want to use each of those triangles to find the missing angle. So look at the triangles that are overlapping, and I want to find that missing angle in the yellow triangle. So I'm going to subtract what I know, the 53 and the 41 from 180, and I get a measure of 86 degrees. Then when I look at the other triangle on the right that's overlapping, to get that angle, I'm going to do 180 minus 72 minus 61, and I get 47 degrees. Now I'm going to use this little triangle that was formed by the bigger triangles overlapping to find that missing angle. So to find that missing angle, I would do 180 minus 47 minus 86. I get a measure of 47 degrees again. Now, 47 and x are vertical angles, so they have the same measure, so x is also 47 degrees. Now, the parts of a triangle. So, the interior angles are the angles that are on the inside of the triangle. So, in this case, we have 1, 2, and 3. So angle 1, angle 2, and angle 3 are interior angles. The exterior angles are angles that are on the outside of the triangle. So in this case, we just have one that is shown, which is angle 4. Now, an important thing to know is that the remote interior angles are the two angles that are not adjacent to the exterior angle. So if 4 is the exterior, then angle 1 and angle 2 are the remote interior angles. So we're going to use this idea for the exterior angle theorem. So in the exterior angle theorem, the sum of the two remote interior angles is equal to the exterior angle. So if I was to draw a triangle with an exterior angle, we'll call this 4 again, 1 and 2. Then in this theorem, we're saying that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2, which should make sense because if I was to add angle 3 in here, remember that 1, 2, and 3 must add up to 180, and 3 and 4 must add up to 180. So if I take away their common part that adds to 180, they must be equal to each other. So let's use this idea to solve for x. So in number 10, we have our exterior angle 13x plus 9 is equal to the interior remote angles added together. So when I combine like terms, 13x plus 9 is equal to 9x plus 63. So I'm going to subtract 9x from both sides. 4x plus 9 equals 63. Subtract 9 from both sides. 4x equals 54. So when I divide by 4, I get that x is 13.5. Remember, it's okay to get decimals. Number 11, my exterior angle is 2x plus 98, which is equal to my remote interior angles added together. Remember that this box is 90 degrees. So 9x plus, or 8x plus 90. So I'm going to subtract 2x from both sides. I get 6x plus 90. I'm going to subtract 90 from both sides. 8 equals 6x. And when I divide by 6 on both sides, I get that x is 4/3, or we could say that x is 1.33 repeating. So number 12, triangle ABC has the following coordinates. A is 4, 1, B is 4, 9, and C is -3, 5. So we want to find the side measures in order to classify our triangle by its sides. So AB is really easy to find because it's a vertical line. So I can just count the distance between A to B. So when I count the distance from A to B, 1, 2, 3, 4, 5, 6, 7, 8, I know that AB has a distance of 8. To find my measure of BC and AC, I'm going to have to use the distance formula. So remember that the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So I'm going to use the distance formula twice to find each side. So first I'm going to find BC. So using those coordinates up here for BC, I have -3 minus 4 squared plus 5 minus 9 squared. Make sure when they're negative numbers, you leave them in parentheses. So I have -7 squared plus -4 squared. So when I square those, I get 49 plus 16. Remember, when you square a negative, you should always get a positive because it was in parentheses. So when I add those together, I get the square root of 65, which I'm going to round to my nearest hundredth, 8.06. So BC has a distance of 8.06. And then I'm going to find my distance of AC. So to find the distance of AC, I use my distance formula again. So I have point A and point C. So I have -3 minus 4 squared plus 5 minus 1 squared. So we get -7 squared plus 4 squared, which is 49 plus 16, which we should be noticing now is the same thing we had for BC. So AC is also the square root of 65, which is 8.06. So if I get the same measure for two sides, remember when we have two congruent sides, so in this case BC and AC, this must be an isosceles triangle. So based on the sides having two of the same measures, this is an isosceles triangle.